Hello, welcome to today's lesson. Today we will be looking at function shifting, which means taking a function and making a change to it, putting a number either in front of the function or adding a number to the end of the function, or changing the x to be some number times x. And how does this affect the graph of the function? With algebra, we can easily figure out how it affects the equation of the function, but how does this affect the graph of the function is what we're particularly interested in. And there are some patterns. Certain things you do to a function, if you add a number to it, it always has the same kind of effect to the graph. If you put a number in front of it, it always has the same kind of effect to a graph. This is the first of 5 videos. We will deal with vertical shifts in this one, then horizontal shifts, then vertical stretches, then horizontal stretches, and then we will look at what you do when you have more than one thing going on in a function, when it's moved in more than one direction or in more than one manner. So for our discussion, we're going to consider this function, f of x equals x minus 1 squared times x plus 3. And the graph of this is shown here. So there's your graph, and we can see some key points in the graph, and they're noted in your notes. We've got an x-intercept here that's, now each one of these grid lines is worth 2, it's worth noting that. So this is like negative 1.7. We've got another x-intercept, touches the x-axis there at 1, at axis 1. There's a relative maximum here, a relative minimum here. And these ends, though there's not an arrow drawn, they go off forever in the direction you see. The right end goes up towards infinity, the left end goes towards negative infinity, and we refer to that as the end behavior. So when we're looking at these graphs, it's important to see what they do when they stop turning around, and that will become more important in future lessons. So, and I could have drawn that arrow at the bottom here, but so here are the observations I made. The y-intercept is at 0, 3. The end behavior is the left points down towards negative infinity, the right points up towards infinity. There's a relative max point at negative 1.7, y is 9.5, and a relative min point at 1, 0. So let's define a function that's similar to f of x, but not quite the same. And what you can see is I've taken my original function, and it's helpful to remember that means this is how we found y. For f of x, the equation we were given was the instructions for finding y. So I'm going to find a new y for each of the same x's by taking my old y and adding 10. Well, that's going to have the effect of increasing every y coordinate by 10. When you graph a y coordinate that's increased, you graph it higher. And if we look at this function, I'm going to have to fix the zoom maybe. No, I guess we can see enough of it. The dotted blue here is our original function, which was x minus 1 squared times x plus 3. The new function, when we add 10, is this dark black function here, the solid black function. So it looks like the x-intercept here changed a little bit. There's no x-intercept here. I moved it all the way up here. This used to be the x-intercept. Where the x-intercepts used to be, they're now at y is 10. Every point in the graph, the max is now at 19.5 instead of 9.5. The min is now at 10 instead of 0. The ends still go in the same direction, so adding or subtracting a number from a function doesn't change the direction of the ends. But I do have essentially the same function with every point moved up by 10 units. Where the point was 0 before, it is now at 10. Right there. Where the point was 0 before, it is now at 10, and that's true for every point on this function. So let's take a look at another difference. So here's the changes. You have different y. Your y-intercept is now at 13 instead of, it used to be at 3 in the old function. So the end behavior stays the same. So here's a list of those changes we saw, but what you can see is the dotted blue function was our original, and adding 10 to the dotted blue function moved the whole graph up 10 units in the y direction. It didn't move it side to side, although it does change the x-intercepts. So another function related to f of x. This time, instead of adding 10, we're going to have we're going to say, well, we're going to find, for our new function, we're going to find the new y's by taking what used to be the y values and subtracting 5. Well, when you subtract 5 from a number, you make it worth 5 less, you make it 5 lower on a graph. And we're not doing anything to the x-coordinates. So we could keep the same x-coordinates, make a list of them, and just take the old y-coordinates and subtract 5 from each. And what that effect that has, subtracting 5, is every point on this graph is now 5 lower. This is at y is negative 5. It used to be at y is 0. This y-intercept is now at y is negative 2. It used to be at y is 3. This maximum point has moved down. This maximum point has moved down 5. Every point has moved down 5. The x-intercepts change, but we haven't moved it horizontally. The only reason they change is because a different part of the graph is crossing the x-axis. But they do change, but the maxes and mins stay at the same x-coordinates. It used to be at x's, the min used to be at x is 1. The min is still at x is 1. It's just its value is different. Where the min or max occurs has not changed, but its value has changed. It's been lowered by 5 because we've only affected the y-coordinates, because this was our y, and we're saying, well, calculate y like you used to, but then take 5 away from it. So every y-coordinate will be 5 less than in the original function. And those points I talked about are all described here. You can compare those to the original. They should all be. So our original relative max point was at 9.5. 4.5 is 5 less than that. Our original minimum point was at 1, 0. It was actually also an x-intercept. Now it's at 1, negative 5. So not just the intercepts and the maxes and mins change, but every point in the graph is moved down 5 by subtracting a 5 from the function. Now, let's look at a new function. You're not as used to seeing functions that are given to you in this manner. But this function is what we call a piecewise function. It's got pieces. This piece is a line, and then there's another line, and there's another line. So in its domain would be from x equals negative 9, including the negative 9, to x is 5, not including the 5. Just as a little review, the range would be, let's see, y is negative 3. Each one of these grid lines is worth 1 to y is positive 3. But this is our function now, f of x. We don't have to define a function with an equation. So our function is there. Now, you're given this, and then what if you're asked, how do we graph f of x minus 5? You have to graph g of x, and all you know about g of x is that it's the same as f of x minus 5. Well, remember, f of x was how we calculated our old y. So the old y values are shown in the graph. Each one of these points, its y value is what I'm kind of referring to as the former, the old y value. The new y is the old y minus 5. Now, if I look at some key points in the graph, I have negative 8, 3 is on the graph. I have negative 5, 0. And I'm just picking these points off the graph. You can take a look at it on your printed notes. Negative 2, negative 3. I'm going to skip ahead here. We really only need the points where it changes direction. 3, 2, and 5, 2. Let's look at these points. So what happens when I take 5 away? This is f of x. So g of x, the x-coordinates are not going to change because all I've done is subtract 5 from y. So I'm going to get negative 8, negative 8. I'm going to get negative 5, negative 5. Notice I'm keeping the x's the same and subtracting 5. Negative 3 minus 5 becomes a negative 8. When you have a negative 3 and you subtract a number, you add the two numbers and keep it negative. 2 minus 5, so the x-coordinates will be 3. 2 minus 5 will be a negative 3. And the x-coordinate stays 5. And in this one, the y-coordinate will also be negative 3. Okay, so we now have the points on our new function. You don't need to do this point by point, but I thought it would help some of you to see where I'm getting this talking about it changes the y. But you can actually look at the graph of the function and just move every point you see down 5. 1, 2, 3, 4, 5. I'll put that one right there. 1, 2, 3, 4, 5. It'll be a little monotonous if I do this for lots of points, but you're gonna get the idea pretty quickly. The important points typically for a piecewise function are the ones where the direction changes, the corner points, because the rest of the shape will stay the same. No matter where this point and this point end up, between it will still be a line. So here I had a -3. I got to go all the way down to -8. 6, 7, 8. This one was a -1, so what I'm doing is taking this -1 and moving it down 5. And I'm doing a little more than the list of points I had there, but just to show you can look right at the graph without making the list of points, and then make your graph, because the object was to graph g of x. That would have been the question you were asked, is to draw a graph of g of x. Now, this one's going to be open, and the rest will be the same. The other end will be closed because it was closed. And you draw from point to point. And what's going to happen is when I'm done here, and this will be a closed circle, that green graph is now g of x. So I had f of x minus 5 is g of x. It moved the whole graph down 5 units. You have to be careful when you're graphing. Here on this graph, each grid line was worth 1 unit. But in our prior graph, each grid line was worth 2. So you want to move it down, not 5 lines, but an amount equal to 5. So if these had been 2 units each, I would have, to move down 5, it would have gone 2, 4, 5. I would have moved that one right there. So you do have to look at your graph and see what the scale is when you do this. So that's moving g of x is f of x minus 5. And here's our f of x again. What if I wanted f of x plus 3? Well, I could do this point by point again, or I could look at my graph and say, okay, each one of these points is going to go up 3. For h of x, the y is calculated by taking my old y and adding 3. Because there is nothing done in the parentheses here. If this plus 3 were in the parentheses, it'd be a whole different thing. We'd be adjusting the x's, not the y's. But if the f of x is by itself still, if there's nothing in the parentheses with what we call the argument of the function or the function variable, what you're changing is y. So I've added 3 to the whole function. The whole function represents the y coordinate, so I'm adding 3 to each y coordinate. So I go 1, 2, 3, and I'm going to do a couple of points just to make it easier for me to draw. And 1, 2, 3, and this one here, 1, 2, 3. That brings that there. And I'm going to have that, and that's going to be a closed circle. And then 1, 2, 3, and then right there, and then there, and then there. So this is now h of x. Sorry, I think I called that one h of x, which was f of x plus 3. I didn't have to even go through that point-by-point list. I can just visually see I'm basically cutting out this graph and moving it up 3. So when you add or subtract a number from a function you have to make a new function, you change the graph by moving it up or down. If the number is added, you move it up. If the number is subtracted, you move it down. So that's the summary right here. If k is negative, then you will shift it down. If k is positive, you'll shift it up. I have 2 problems for you to try on the next page. So we have the same function f of x we had before, and I'm asking you to graph f of x minus 2. That's the first problem to try, and then the next problem to try is on the next page. Stop the video and try these 2 problems, and then come back to see how you did. Okay, so you're back. So I assume you tried these, because that's the best way to do it. Even if you do it wrong, trying it is actually helpful to your learning. So I had to graph f of x minus 2 for this one. Sorry, I'm having a little trouble with the pencil here. And it's not turning to an eraser, and it's supposed to. There we go. All right, so I have f of x minus 2. So I'm just going to move the graph down 2. This becomes a big red circle, the big filled in circle. This becomes a open circle, and each point just moves down 2. So I'm just drawing these all in to make it easier for me. If I had a ruler, I could just draw this point and this point and draw between them, but it's going to be tricky for me to connect them if I don't draw more of them. Oh, I see a mistake. I only made that a 1. I only made that go down 1. Let's try that again. So that goes down 2, this goes down 2, this goes down 2. There we go. It should be the same shape as the original function. It should be a line. And then here I'm down 2. There I'm down 2. And there I'm down 2. And there. And then across there. It's hard to see that, but this will follow along next to each of these is 2 below. So that should be your new function. That's your g of x in green. So when you subtract from the original function, you move the graph down that much. Now, in our next problem, we added 4 to the function. So we're going to move that up 4. 1, 2, 3, 4 for this point here. And let me move this so we can see more of the graph. 1, 2, 3, 4. 1, 2, 3, 4. And that's going to be a line. And then here, I'm moving up 1, 2, 3, 4. 4. And 1, 2, 3, 4. And this will be right there. This open circle moves up 4 to there. So I have function there. And then there. So this is my graph of h of x. It's f of x plus 4. F of x is in the solid black line. And when I add 4 to it, I get g of x. Or I think I said this was h of x. Is in the green. So what you need to walk away from is that rule that when you add a number to the end of a function, or even you could do f of x plus 4 is the same as 4 plus f of x. Don't forget that. And or if you had a negative 2 plus f of x, it would be the same as what we did in the first problem you did on your own. So this is putting a negative 2 and adding the function is the same as subtracting 2 from the function. Putting a 4 and adding the function is the same as adding 4 to the function. So keep that in mind when you add or subtract, either before, in front of the function or at the end of the function. If you're not connecting anything to the x, you're not changing any horizontal coordinates. All of these points here have the same x coordinates as the points in the original. You're changing the y coordinate. If you're adding a number, you're adding to the y. If you're subtracting a number, you're subtracting. So that's it for today's video. Take a look at part 2 to see what happens when you do put the number, like the x plus 4, in the parentheses with the x.